So we're continuing to look at examples of linear models, and we're going to learn a new technique in this lecture. So let's dive into this example. In 1997, Allergan earned $90 million in sales of Botox. Revenues from Botox in 2001 were $310 million. Notice that these sales figures are annual values. So the application domain is going to be a little bit different. So we just have integer years 0, 1, 2, 3, 4, and then each one of those integers corresponds to an annual revenue. So we don't have like January revenue, February revenue. We just have 1 year per revenue. So our domain is discrete. Assume the revenue changed at a constant rate, therefore linear, with respect to time, and that this trend continues. So our first task is to find a model that gives Botox revenue R in millions of dollars as a function of T, the number of years after 1997. So number of years after means elapsed time. And elapsed time means y equals ax plus b is our model. Okay, so that means that we need the slope and the y-intercept. So looking at the information that we're given, we have basically 2 points. We have 90 million at time 0 and 310 million in 2001 is going to be time, what is that, 4, right? So if I was going to kind of draw a little graph of this, it would look something like the following. So this is elapsed time, so we are going to start at time 0 with, I forgot what it was, 90 million. Let me bring back that picture. So this would be 90, and then 0, 1, 2, 3, 4, we're at 310. Okay. And so we want to find a model. Now this is going to be a little bit strange because we want to find the model of the line connecting these two points, but we're also going to be aware of the fact that it's not actually a line. It's actually just going to be, let's put these in a different color. It's actually just going to be discrete points that fall along the line like that. Okay. Because we don't actually have values for the intermediary points. But nevertheless, we're basically going to do this the same way. I need to find this. I have the y-intercept. That's my b value right there. That's b. So b equals 90. But my slope is going to be 310 minus 90 divided by, what's my time? 4 minus 0, right? So, quick computation, that's 55. So our model is y equals 55x, or t rather, and this should be p actually, sorry. How about I just erase it? 55t plus 90. Okay, so that's great, and with that in hand, we can now answer these questions. When does the model predict for what does the model predict for Botox revenue in 2010? That's going to be our standard vars y vars question. So we'll input the elapsed time of 2010, which is, what is that, 13 years. And we can do that in just a moment. And then part C, according to the model, in what year will revenue reach $500 million and $1 billion? So again, that's it's pretty somewhat standard. That's a type 2 question, so we would use calc-intersect for that. So that's great. But what I actually want to focus on is there's another way to generate this model that is an important method and is a nice little shortcut. And I want to go ahead and show that to you. So whenever you are given 2 points, let me make this clear what we are given here. So if we are given 2 points, you can use, if you want, this technique called linear regression. Or you can use the point slope. Or the slope y-intercept. I was about to go into that, but let's actually just focus on linear regression. That's the point right now. So I want to show you how to use linear regression for this. Even though we already have the model, I want to show you this other method. So the linear regression method works as follows. The first thing that we're going to do is we're going to enter the 2 points that we're given. So the 2 points are 0, 90, and 4, 310. All right, those are my 2 points. So I'm going to enter these 2 points in my list editor. So I go to Stat, turn on the calculator, go to Stat, Edit, and actually I want to clear these lists. So let me go to Second Mem and choose, what did I just do? Sorry about that. That's Second Mem, clear all lists. And now when I go to Stat Edit, my list will be empty and I can put stuff in there. So my list 1 is going to be this first column, 0 and 4. It's the X values, or the T values. And the second column will be the output values. Okay. And what we're going to do now is tell the calculator to find the line passing through these points. And the way we do that is as follows. We go to Stat, Calc, LinReg. I'll do that again. So hit Stat, Calc, scroll down to LinReg, then hit Enter. Now, we want to be sure that it's using the correct data. So I type second L1, comma, second L2. That's basically telling the calculator to use, for its function data, use the information in list 1 and then the information in list 2. And then lastly, I want to tell the calculator where to save it. So I type in vars, yvars, function, and I choose what I want to save it as. So I'm just going to save it as y1. So now it will save the function as y1. And there it is. ax plus b, where a is 55 and b is 90. And we know that that's the same one that we found already, and there it is. Let's erase that second function. That's from another example. Okay, so the linreg method is great for these kind of scenarios where you're given 2 data points. You can just type them in and it'll spit out the line for you. So that's nice. So now let's go ahead and answer this next question. So the question says, according to the model, in what year will Botox revenue reach 500 million and then 1 billion? 1 billion, by the way, is 1,000 million. So that'll be the actual number that we use. Okay, so with that in mind, let's talk about how to do this. Now, normally you would do a problem like this just using calc-intersect, but the fact that we have this kind of weird application domain, it's actually going to be better for us to use the table here, and let's talk about why. So let me pull this up. Now we want to know what what year will revenue reach 500 million. So we're looking for this to meet or exceed 500. And remember, we only have 1 year. Each year has only one revenue associated to it. Okay, so let's go to the table, and I forgot I've got to change my table set because I'm at 2004. So let's go back to second table set and start at year 0. And now I'll go to table, and we're just looking to see when we pass 500, and there it is. The first year in which we are past 500 is year 8. So year 8, let's make a note of that. Now let's go ahead and do 1 billion as well. So when do we pass 1,000? So I'm just scrolling down, and I pass 1,000 right there in year 17. Okay, so do you see how in this example using calc-intersect is not really necessary? I just need to know the pure integer year when I exceeded this value. I don't actually need to know the decimal value because we don't have a decimal portions of years. We only have whole years. Okay, so 8 years after 97 or 17 years after 1997. And let me go to the answer, which is right here. So that would be 2005 and 2014. Okay, so that example actually had several different new techniques that we learned. I don't want you to think that every example, that all of those things have to always occur at the same time. But whenever you're given 2 data points, you can use linear regression to find the line if it's a linear function. And the other thing is that if your domain is discrete in the sense that it's just these values 0, 1, 2, like we see here, then you can just use the table to get your intersections. Okay, great.